Hello everyone, I'm Rajasri, Assistant Professor, Department of Electrical and Electronics Engineering, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing Class C choppers. And here, if you see, we are making use of two transistors and two diodes. And basically, this Class C chopper, it is combination of both Class A and Class B chopper, such that Class A, it will be facilitating the first quadrant of operation, whereas Class B, it will be facilitating the second quadrant of operation. And here, Class C chopper, it provides both first quadrant of operation as well as second quadrant of operation. That is, if you see here, firstly, transistor 1. When the base drive is actually provided for the transistor 1 starts conducting current through the load. And that is how T1 conducts, and here energy flows through the load in this direction. And this is how actually current flows through the load. That is, let us name this as point A and this is point B, and current flows right from point A to B. That is the only reason here voltage is positive as well as current is also positive, thereby facilitating the first quadrant of operation. And firstly, we need to know what is the importance of first quadrant of operation. That is, since voltage is positive as well as current is also positive, this facilitates forward motoring operation, or we can also call it as a rectifying operation. Why is it called as rectifying operation? It is because power is flowing right from source towards load. Power is fed from right from source towards load. So that is the reason this is rectifying operation. In other words, forward motoring. That is, motor will be rotating in the forward direction. So that is the thing. And when transistor 1 is conducting, there is a presence of an inductor over here. And because of the presence of the inductor, initially inductor will be charging with polarities positive and negative. And once the completely T1 is off, in that case, this particular inductor polarities will be turned out to be negative and positive. And because of such polarities, and we all know inductor has a property, it tends to maintain the current flow in the same direction even when T1 is turned off. It tends to maintain the current flow in the same direction. So because of the presence of the energy stored in the inductor, the energy stored in the inductor will be driven current through the D2. That means once the transistor 1 is turned off, at that instant, this particular, because of the polarities across the inductor, it tends to maintain D2 in a forward bias position. Because of the polarities across the inductor, D2 will be forward bias and D2 will be conducting a current through the load in this direction. That is, from, again, power flows from A to B. The current direction will be from A to B, and that is the reason even here it will be providing the forward motoring or rectifying operation, that is first quadrant of operation, because current flow here is positive, and that is the only reason the freewheeling operation will be taking place through diode 2. So during the first quadrant of operation, initially T1 is being triggered, and when T1 is conducting, it is driving the current through the load in this direction, and it is facilitating the first quadrant of operation. And as soon as when T1 is turned off, at that instant, because of the polarities across the inductor and its inherent property, in order to maintain the current flow in the same direction, that is the only reason the polarities across the inductor is making D2 forward bias, such that D2 is now conducting current through the load in the same direction. And because here current is positive as well as voltage is positive, it is facilitating first quadrant of operation even when D2 is conducting. So T1, transistor T1 and diode 2 is providing the first quadrant of operation. And once whatever the energy stored in the inductor is completely dissipated, at that instant we provide the base drive for the transistor 2, such that now transistor 2 is conducting a current through the load in this direction, that is from B to A. So during which the current direction will be negative. And if you see, when T2 is conducting, current direction, since it is negative, why are we calling it as negative? That is because current is flowing in the reverse direction of that of the first case, that is from B to A. Whereas in the previous cases, current is flowing from A to B. That is the reason there the current was positive. And now when T2 is conducting, the load current is in the reverse direction. That is the reason the current is indicated as negative. So if you see here, voltage is positive whereas current is negative. That means it is providing the second quadrant of operation. And here current is negative in the sense energy is flowing right from load towards source. That means it is inverting operation. Previously, power fed from source, right from source towards the load, whereas now current is flowing right from load towards source. That means power is fed back from load towards source. That is the reason we call this as forward regeneration, or we can also call it as inverting operation. Because power is fed from load towards source, we call it as inverting operation. And here forward regeneration. Why do we call it as forward regeneration? It is because the motor is always running in a forward direction. So that is the reason here this is forward regeneration. Because voltage is positive, motor will be rotating as it is in a forward direction, whereas current flowing will be in the reverse direction. So here thereby it is facilitating the second quadrant of operation whenever transistor is conducting. And also we need to note this point, whenever transistor 2 is conducting, at that instant current is flowing in this direction. That means the polarities across the inductor initially will be positive, negative, and by the time the inductor is completely charged, the polarities across the inductor will be positive and negative. That means the moment when we withdraw the base drive for the transistor 2, at that instant this transistor 2 is now turned off. So whatever the energy stored in the inductor, it tends to maintain the current flow in the same direction. And that is the only reason the polarities across the inductor will now forward bias diode 1. And now diode 1 is turned on, and thereby whatever the current in the energy stored in the inductor will be dissipated through load, through D1 and back to source. That means now current direction is from B to A. Since current flowing from B to A, that means current direction is negative. And here, whereas voltage is positive, but current is negative, that is the reason we call it as inversion operation. That is, power is fed right from load towards source. So what we call it as inversion operation, but the voltage polarities are not changed. So that is the reason this we call it as forward regeneration. Hope you understood this point. And this is all about the class C chopper, which provides both first as well as second quadrant of operation. And let us move on to the class D chopper. So here in class D chopper, initially T1 and T2 will be conducting current through the load. So the moment when we provide the base drive for the transistor 1 as well as transistor 2, at that instant current will be flowing through the load in this direction. That is T1, load, T2 and back to source. That is, we can name the load terminals as A and B. That is, output current through load is flowing in this direction, that is positive. Current now is positive as well as voltage is also positive. That means the first quadrant, it is facilitating first quadrant of operation, that we call it as forward motoring. And since power is flowing right from source towards load, so that is the reason we call it as rectifying operation. We call it as a rectifying operation or forward motoring. Since motor is rotating in the forward direction, we call it as forward motoring. And this is the first quadrant of operation. And now, once the inductor is completely charged, in that case, in order to maintain the current in the same direction as that of the first case, so that is the only reason the polarities across the inductor will now make D1 as well as D2 forward bias, such that now whatever the energy stored in the load will be fed back to source. So if you see, D2 is conducting and whatever the energy stored in the inductor is making D1 and D2 forward bias, since we have withdrawn the triggering pulses, that is base drive for the transistor 1 and 2, and now these two are off. So whatever the energy stored in the inductor, it should be dissipated, and at the same time this inductor tends to maintain the current flow in the same direction as that of the previous case. That is the only reason it is making D1 D2 forward bias, such that now power stored in the load is fed back to source. And here current flow is in the same direction, that is current is remained positive, whereas voltage is reversed. So that is the reason here voltage is negative, output voltage is negative, whereas current is remained positive. That means it is facilitating the fourth quadrant of operation. Fourth quadrant of operation, where fourth quadrant it is for reverse regeneration or inverting operation. Reverse regeneration or inverting operation. Why do we call it as reverse regeneration? It is because the voltage polarities have been reversed, and that is the reason we call it as reverse regeneration. And coming to the inversion operation, that is power is fed right from load towards source. That is the reason this is inversion operation. And here thereby the class D chopper is providing first quadrant of operation as well as fourth quadrant of operation using T1, T2 as well as D1, D2. Coming to the class E chopper. Class E chopper, this is a chopper which provides all the four quadrants of operation. If you take class A chopper, it is providing first quadrant of operation, whereas class B chopper, it is providing second quadrant of operation. Coming to class C, it is providing both first as well as second quadrant of operation. This is the combination of both class A and B. Whereas class D chopper, if you take, it is providing both first quadrant as well as fourth quadrant of operation. Whereas class E chopper is a chopper which provides all the four quadrants of operation. And you know very well, first quadrant of operation where voltage is remained positive as well as current is remained positive. That is, it provides forward motoring operation. Since voltage terminals are remained as it is, motor will be rotating in the forward direction and the current flow will be right from source towards load. That means this is rectifying operation and current flow direction will be positive. And whereas second quadrant of operation, and here in the second quadrant of operation, voltage is remained positive whereas current is negative. So this is nothing but inversion operation. Why is it called as inversion operation? Power is fed right from load towards source, and here since voltage terminals are remained positive, we are not reversing any voltage terminals. So what? Motor will be rotating in the forward direction and we call it as forward regeneration. And coming to the third quadrant of operation, here current is negative as well as voltage terminals are also reversed. So thereby output voltage is negative. And since we are reversing the polarities of voltage, here motor will be rotating in the reverse direction. So what third quadrant stands for? Reverse motoring, or we can also call it as rectifying. It is because here current power flows right from source towards load. So that is the reason this is a rectifying operation. And coming to the fourth quadrant of operation, here current remains positive, whereas voltage terminals are reversed. So that is the reason we call it as reverse regeneration, or otherwise we can also call it as inversion operation. Why do we call it as inversion operation? Power flows right from load towards source. So what we call it as inversion operation. And here, in order to obtain all these four quadrants of operation, initially base drive will be provided for the transistor 1 as well as transistor 2, such that T1 conducts current through the load from point A to B. So that is the reason, see, current will be flowing in this direction, and then T2 and back to source. And here if you see, current is positive as well as voltage is also remained positive. So that is the only reason this is providing the first quadrant of operation, that is which stands for forward motoring, or we can also call it as rectifying operation. And now see here, we are withdrawing the base drive for the transistor 1, and that is the only reason here transistor 1 will be turned off, and now T2 is still remained in conduction. So in order to provide the closed path, D4 is forward bias, and thereby current is now flowing through the load from D4 through load T2 and back to D4. And if you see here, current is flowing from point A to B. That means current is remained positive, whereas voltage is 0. So that is the reason this is forward motoring operation. That is, it provides first quadrant of operation, or we can also call this as rectifying operation. And now, once T2 is also turned off, that is when the base drive for the T2 is withdrawn, in that case, see, there is a presence of the inductor, and this inductor tends to maintain the current flow in the same direction as that of the first two cases. So that is the only reason this particular inductor forward bias is D3 as well as D4. And thereby, if you see, current is flowing right from point A to B. That means current is remained positive, whereas voltage is reversed. So that is the reason here voltage is negative, output voltage is negative, whereas current remains positive. If voltage is negative, that means that is fourth quadrant of operation. And in the fourth quadrant of operation, this is reverse regeneration, or we can also call it as inversion operation. And why is it inversion operation? If you see, current is flowing right from load towards source. So that is the reason this is inversion operation. And the energy stored in the inductor is now completely dissipated. The period during which when T1 and T2 was conducted, inductor has charged, and once the pulse is being withdrawn for the transistor 1, in that case T1 was turned off, and this inductor, since it need to maintain the current flow in the same direction, D4 is being forward biased, and current flown through D4, T2 and back to D4. And now by the time when we withdraw the triggering pulse for T2 as well, T2 is turned off, and inductor, because it need to maintain the current flow in the same direction, it has forward bias D3 as well. So current flow through D3, source, D4 and load. This was the current direction. And now, by now, here we have provided the triggering pulse for the transistor 3 as well as transistor 4. We have switched on T3 and T4. And if you see, when T3 and T4 is turned on, current flow through the load will be in this direction. That is T3, load, T4 and back to source. And if you see, the points across the load will be B and A. That is, current is flowing right from B towards A, and that is the reason, if you see, the current flow is in the reverse direction to that of the first case. If you see these three cases, current was flowing from right from A to B, whereas now it started flowing from point B to A. which is exactly reverse to that of the first three cases. So that is the reason here current direction is negative, and current direction is negative as well as voltage polarities is also negative, and that is the reason this will be facilitating the third quadrant of operation, where third quadrant of operation is nothing but reverse motoring. Since voltage is negative, voltage terminals are reversed, and at the same time current is also negative. So that is the reason this is reverse motoring, or else we can also call it as rectifying operation. Why is it rectifying operation? Current is flowing right from source towards load. So that is the only reason this is rectifying operation. And this is all about the third quadrant of operation. And by now, since we have withdrawn the base drive for the transistor 3, now that transistor 3 is turned off, and when transistor 3 is turned off, now current flow is facilitated through T4, D2 and load and back to T4. And if you see, current flow is now from point B to A. That is, current is negative. That means since the current direction is negative, this is facilitating the third quadrant of operation. And here output voltage is negative, as well as output current is also negative. Thereby it is facilitating the third quadrant of operation, where motor will be rotating in the reverse direction, and this is rectifying operation since current is flowing from load towards source. And that is all about this. And once the energy stored in the inductor should be completely dissipated, the moment when we withdraw the triggering pulse for the T4, at that instant again D1 will be forward bias. Now D1 comes into the picture once the T4 is turned off. Thereby, and because of the presence of the inductor, it tends to maintain the current flow in the same direction. So that is the reason here D2 is conducting current through load, D1 and back to source. And that is all about the second quadrant of operation. Second quadrant of operation, where voltage is remained positive, whereas current direction is negative. Why am I saying current direction is negative? If you observe, current is flowing right from point B to A, that is in the reverse direction. That means current is negative. So that is the reason voltage remained positive, whereas current is negative, and thereby it is providing the second quadrant of operation, where second quadrant of operation stands for forward regeneration, or we can also call it as inversion operation. Why is it inversion operation? Current is flowing right from load towards source. Power is transferred right from load towards source. If you see, this is the direction. So that is the reason we call it as inversion operation. So that is all about the class E chopper. This is the only chopper which provides all the four quadrants of operation. And this can also be used in reversible DC drives. That is the application of class E chopper. And in the upcoming lecture, we'll be seeing inverters. Thank you.